Okay, so question 7, we're given a nice little diagram there of a transverse wave. And we're asked to find, firstly, what is the wavelength of this wave? There are loads of different ways we could do this. We could start off by here and say, well, that is one wavelength. Let's change to red to this point here. So we could have a look at that distance there. That's one wavelength. And you read that off there. I'm reading that as about 3.5 for a first approximation. 3.5 centimeters we're in. Another way you could do it is say, well, hang a second. We're struggling to read exactly it there. Let's go for 2. How long is 2 wavelengths? So if I go from the beginning to the end here, well, 2 wavelength is 7 centimeters. So that was for 1 wavelength, it was 3.5. So 2 wavelengths is 7 centimeters, which goes in the right trend. If you want to make life difficult for yourself, you could always have a look and try and work out where the tops of the peaks are, or even the troughs. But you'll have to remember to take the numbers away from each other here. And it isn't exactly spot on to do this because it's difficult to tell exactly where the peaks are from there. Personally, I prefer this method to work out what 2 are, or the most amount of wavelengths. So how many total wavelengths can we fit in there, and then divide it. So in this case, we've got 2 wavelengths over 7 centimeters. So therefore, that gives us wavelength is 3.5 centimeters, which confirms our initial value there. So that is 3.5. And, oh, they've given us centimeters. I always like writing it in anyway. The amplitude of the wave, amplitude. So that's going to be the value from the middle to the top of the wave. So from the rest position to the top, reading across there, I think that is 2.4 centimeters. The wavelength is changed to 25 centimeters. So now the wavelength is 25 centimeters. Notice the centimeters, that could be important. 2 waves are produced each second. So there are 2 waves in a second. Use the equation wave speed is frequency times wavelength. Calculate the wave speed, the speed of the wave. Well, frequency times wavelength. What's the frequency? Well, frequency is how many waves are there a second. How many waves? Oh, we're told 2 waves are produced each second. So the frequency is 2 hertz. The wavelength is 25 centimeters. So that's 25 over 100. Okay, so we could rewrite that as 2 times, or that is 0.25 meters. And again, let's do that in our heads. That's nice and easy. 0.50 meters per second. Last one on this page. We're now tested to see if we understand the difference between longitudinal and transverse waves. Water waves are transverse, sound are longitudinal. Describe how the particles in a transverse water wave. Describe how the particles move. I missed out that key word there. How do they move in a transverse water wave? So if you remember transverse wave looking something like this, the idea is that the wave is moving in that direction, but the particles are vibrating at right angles to it. So you want something along the lines of, so how they, let's just trouble that question. Describe how the water particles move. So they move at right angles. Or you could say perpendicular to the direction of the wave. When we say move here, I'd be tempted just now to read back to that question, say a better word there would be vibrate. They vibrate at right angles to perpendicular. Yeah, that sounds a bit better, doesn't it? Describe how the air particles move in a longitudinal wave. So again, longitudinal waves, you have the compression and rarefactions like this. The wave again is moving in this diagram from left to right, but this time the air particles are vibrating parallel to that direction. So they're going like backwards and forwards as the wave goes forwards. So let's make sure we remember that, they vibrate parallel. to the wave direction. Job done.